Everyone, I'm Saurabh. In this particular series of lectures, I would be telling you all about automata theory. So, it is one of the main subjects which is being taught to all the students of second year. One thing I want to tell is that I'm going to cover each and every topic which is important. So, I will be covering the whole syllabus. I won't be missing any of the topics. So, first of all, I would like to tell you that what automata theory basically is. There are two words in this particular name. The first one is the automata. When you see that the first term is automata and the second is the theory. So the term automata, what does it mean? Automata basically means the abstract computational device. So an abstract computational device, you know that human beings are capable of doing many things, and we want to make machines that can do things as human beings can do. So for this, we make computational devices. You all have seen calculators. Calculators are capable of calculating numbers, having different operations, and similarly, you can use the modern day computer. Computer is capable of doing lot many things. It is much more capable than a simple calculator. So all these are computational devices, and there is a specific classification of computational devices. A particular set of computational devices are capable of performing some tasks, and there is another class of computational device that is capable of performing some more tasks. There is some other class of computational devices that is capable of computing some more operations. So, for this particular reason, we have to study this subject. In this particular subject, we will be discussing what different computational devices are there, and the classes of the computational devices and the capabilities of the different classes. Uh, we have a particular hierarchy known as the chemistry hierarchy, in which we have different classes of computational devices. So I hope that this is clear to you all. When we say that abstract means theoretically we are going to discuss, and we will be discussing of the machines. In we can also say that we would be discussing about the machines. Let's begin. The very first type of the automata is known as the finite state automata. So what a finite state automata is, basically, you know that if you ask someone to calculate something, like if you ask someone to have a string and tell that whether the string starts with a 0 or a 1, if you have only two alphabets, that is a 0 or a 1. So, or if you have A or B as an alphabet, and I ask someone that whether the person can tell that recognize all the strings that are starting with a particular alphabet A, like this. So what you all are going to do is that, suppose if there are certain strings with you all, like this is a string, this is also a string, this is another string. So like this, you may have many different strings, but if you ask no one that how does to recognize different strings starting with the alphabet A, it can have multiple A's also, but the main thing is that the string must start with A. So all these types of strings will be accepted by the person, and all these won't be accepted. So these won't be accepted. So for this particular type of example, what you do is that you are going to concentrate on the first alphabet of this particular string. Okay, and if the first alphabet is a A, then you are going to accept that particular string. And if it is not an A, then you are going to reject that particular string. So there are two things, that either you are going to accept a particular string or you are going to reject a particular string. You have a string as an input, string as an input. So in the same way, in the finite state automata, we make certain states, and as I've said, that we are going to theoretically discuss these things, that how the computational machine is going to recognize all the strings starting with A. Necessarily, what I have told is that only the alphabets which we have are A and B. So we actually, for this particular type of problem, what we do is that we are going to first of all define the set of the alphabets. So over here I've already said that we have only two alphabets, A and B, so all the strings would be comprising of only A and B, necessarily A and B and not any other alphabet other than A or B. So we say that we have a set of alphabets that is represented by sigma, and what the set is, it is comprising of only two alphabets, A and B. Similarly, for all these strings, what we say is that actually, when we say A and B, there can be many alphabets. There can be many alphabets, but there is a feasible set of alphabets which we are going to consider at a particular instance. Suppose over here we are discussing and we are considering only A and B. So there can be many alphabets. So we can say that there can be many symbols. Okay, you know that in English language, you know that there are many alphabets. We have A, we have B, we have C, we have D, so on till Z. But in our example, we are considering only two symbols out of these, only A and B. In fact, we can have symbols like numbers also. We can have 0, 1, 2, and so on also. So we can have infinite number of symbols, but main point over here is we are going to concentrate on a set of on a subset of this symbol, and this set is said as the set of alphabets. This is the set of alphabets, and this is a finite set. Main point is this is a finite set. Symbols are infinite. There are infinite number of symbols, but this set in particular is a finite set. So we would be having a finite set of symbols, and we will be having the strings, and these all are the strings. So what we say is that for any particular problem, we will be recognizing the language. So when we say the term language, we mean the set of the alphabets, the set of the strings which are going to belong to that particular language. Suppose in this particular question, when I say that recognize, so the question over here is recognize all strings starting with alphabet A. So we know that for this particular line, let us denote it by suppose L over here. So we can just replace it, and we will say that L over here will be comprising of the strings like A, 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 B, A, 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 B, A, B, A, and so on. There would be infinite number of strings in this particular case. Okay, so we have to recognize this language, and we are having only two alphabets A and B. So what we say now overall we have three necessary terms if we want to understand that what a particular machine is going to perform. So for a particular machine to recognize all the strings starting with A, first of all we should have a particular set of alphabets, and that alphabet is a finite set from the set of symbols which is in fact infinite. We can have infinite symbols, and we have the strings. Second thing is the string. We have strings which are made from these particular alphabets only, and a particular set of the strings which are belonging to our language. So we want to design a machine. We want to design a machine that is going to recognize all these alphabets. Oh, sorry, all these strings. So you know that there can be infinite number of strings, but we are going to accept only those strings which are starting with the alphabet A. So for this particular type of a problem, we have a simple machine that is known as a finite state automata. In short, we say FSA. FSA is a finite state automata. So for this particular question, as you know now that there the three important things are the set of the alphabet, the set of the strings, and the language. The language is the set of the strings which belong to this particular question. Okay. So for this particular question, we have to design a machine now. Actually, this machine could have states. So for this particular reason, we say that the name of the automata is a finite state automata. States. We have states. There is a state diagram, and we have states. We can represent states. There are three main types of states. The first is the start state. Start state is a state which is represented by an arrow along with a circle. So this is the representation of any state. All the states are represented by a circle, but this particular state, which is the start state, so we have to place an arrow before the circle. So this is going to distinguish the this state from all other states, because this is a specific type of a state which is known as the start state. Secondly, all rest states can be represented by a single circle, but there is another specific type of a state which is known as the accept state. As I have told that there are a particular set of strings that are going to belong to the language, and there is going to be a particular set of strings that are not going to belong to this particular language which has been asked. So all these strings which are belonging to the language would end up in this particular state, which has the double circles. Suppose in this particular question, if we think we have two alphabets, and what a human brain is going to do, if someone wants to do the same question, if someone wants to answer the same question, it wants to recognize the language that is the set of strings that are starting with the alphabet A. So what you are going to do is that you are going to recognize, you are going to concentrate upon the first alphabet. And if the first alphabet is an A, then you are going to accept that string. Else you are going to not you are not going to accept that string. Okay, we will be rejecting that string, but rejecting means rejecting in this particular case of automata, which is known as the finite state automata, rejecting means that we are not going to end up in the exact state at the end of the string. So suppose we know that we have to start with the start symbol. So start symbol is over here, and arrow which is ahead of the circle. So this is the start state. We know that we can have possibly two alphabets. The first one is the A, and the second one is a B. So for all those strings which start with an A, we are going to transit into another state. And you know that if we are going to have an A in the start of any string, so the main thing is that you are going to, like suppose there is a string, so we are going from in the string from left to right, left to right. So the leftmost alphabet is A. So we will be having the first alphabet, that is the leftmost alphabet, the first one that we are going to encounter. And then after that we know that we can have any alphabet, either it can be A or B. So we don't need to change any state now. Okay, we know that if we have got an A, then necessarily this particular string, whether it is having any further A or B, or it is having nothing, then also it is going to be belonging to this particular automata which has been asked. The language of the automata will be having this particular string. So single A is also there. In this particular case, we can have A followed by A, we can have A followed by B, A followed by more number of A's, or A followed by more number of B's, A followed by any combination of A or B, or B or A. So we can have infinite number of strings. Okay. Other than this, uh, some of you might be thinking that what happens if we are going to encounter a B in the beginning. So for that reason, if you are going to encounter a B, you would not be considering this string in the language, and we have a special type of a state which is known as the dead state. It is a type of a trap. So why I'm saying it is a trap, because once a particular string enters into this particular state, it is not going to move to any other state now. It is going to be over here only. So this is known as the trap. Is we call it as a dead state. Hopefully, in this example, you can understand that what are the three things which I have told. First one is the finite set of symbols known as the alphabet. Over here it was A, comma, B. The second thing was the set of the strings. You know that the string is any combination of alphabets. Combination of alphabets. You know that I'm writing over here alphabet and not symbols, because the alphabet is a particular subset of the symbols which we are going to consider for any particular language. By language over here we mean all the strings which are belonging to the question which has been asked. So we say that the third thing is the language. Now language can be both finite or infinite, but what language is? It is the set of strings belonging to, yeah, so belonging to our question. So it was the thing which we were finally trying to recognize. We were trying to recognize the strings which are belonging to a question. That is, we can say that it is the set of the strings belonging to a language. Okay. Thanks. Hopefully you have understood all these things. This is the dead state. Okay.